It's physically possible, so I think we can do it, and I believe he's legit. From everything I've looked at, this guy actually made something that could totally revolutionize the world. Elon Musk unveils a revolutionary lightspeed engine that could redefine the laws of physics as we know them. We finally figured it out, and I think this is the way that all electric cars in the future will ultimately be made. 2 new products that I believe will excite people. Could this be the next leap for space exploration, bringing interstellar travel within reach? At a certain altitude, you can go supersonic. Some of these conspiracy theories have actually turned out to be true. Join us as we dive into Musk's latest technological breakthrough, exploring how this engine challenges conventional science and what it means for humanity's journey to the stars. People always want to know what our next product is. We are actually building a new one, and we are currently designing it. Elon Musk, the visionary founder and CEO of SpaceX, made a historic announcement that has left scientists, engineers, and space enthusiasts around the world in awe. During a press conference at SpaceX headquarters, Musk revealed a new propulsion technology that he claims can achieve light speed, an astonishing feat that has long been the stuff of science fiction. The revelation comes after years of speculation and anticipation. Musk, known for his ambitious projects and revolutionary ideas, has taken yet another giant leap forward with this announcement. But what exactly did Musk unveil, and why is it so significant? Let's break down the details. To grasp the magnitude of Musk's announcement, we need to understand what light speed actually means. Light travels at a mind-boggling speed of approximately 299,792,458 meters per second in a vacuum. Given the vastness of space, this speed is a fundamental limit, according to Einstein's theory of relativity. Nothing with mass is supposed to be able to reach or exceed this speed. Einstein's theory posits that as an object approaches the speed of light, its mass effectively increases, requiring an infinite amount of energy to reach this speed. This has been a cornerstone of modern physics and a key barrier in our quest for faster-than-light travel. Musk's lightspeed engine, which he has dubbed the warp drive propulsion system, is designed to circumvent these fundamental constraints. According to Musk, the engine operates on principles that challenge our conventional understanding of physics. Here's a closer look at the technology he has revealed. The basics of the warp drive propulsion system are inspired by theoretical concepts that have been explored by physicists but never realized in practice. The core idea behind the warp drive is to manipulate space-time itself, creating a warp bubble that contracts space in front of the spacecraft and expands it behind. The theoretical foundation of Musk's engine is rooted in the work of physicist Miguel Alcubierre, who proposed the Alcubierre drive in 1994. Alcubierre's concept involves stretching and contracting space-time, effectively allowing a spacecraft to travel faster than light relative to the space around it without locally exceeding the speed of light. While the concept is theoretically possible, engineering a practical warp drive presents enormous challenges. The energy requirements for creating and sustaining a warp bubble are currently beyond our technological capabilities. However, Musk's team claims to have made significant progress in overcoming these challenges, though detailed technical specifications are still scarce. To understand how Musk's lightspeed engine works, let's break down its key components and processes. First, the engine generates a warp field by manipulating spacetime through advanced energy fields. This involves creating a differential in spacetime geometry, which allows the spacecraft to move within the warp bubble without breaking the speed of light locally. Essentially, the spacecraft remains stationary within its bubble while the bubble moves faster than light. One of the most significant hurdles in developing a warp drive is the immense energy required. The warp drive propulsion system reportedly utilizes new energy sources that are not yet fully disclosed. These sources are designed to provide the enormous power needed to create and maintain the warp bubble. Controlling and stabilizing the warp bubble is crucial for safe and accurate travel. The system includes advanced guidance and control mechanisms to ensure the spacecraft remains within the bubble and avoids potential distortions that could impact its trajectory. The implications of a functional lightspeed engine are profound and far-reaching. Here's how Musk's warp drive propulsion system could transform space travel and exploration. Interstellar travel is currently a monumental challenge. Even the closest stars are light years away, making such journeys impractical with our existing technology. With a light-speed engine, the vast distances between stars could be traversed in a fraction of the time, opening up new frontiers for exploration and colonization. Humanity's long-term survival may depend on our ability to establish colonies beyond Earth. The warp drive propulsion system could make interstellar colonization feasible, allowing us to reach and inhabit distant exoplanets that were previously beyond our reach. Faster-than-light travel could also revolutionize space research. Scientists could access distant regions of space and gather data that would otherwise be unattainable, leading to breakthroughs in astrophysics, cosmology, and our understanding of fundamental physics. While the potential benefits of a light-speed engine are enormous, there are numerous scientific and technical challenges that must be addressed. One of the biggest challenges is the energy required to create and sustain a warp bubble, which is currently beyond our capacity. Estimates suggest that the energy needed could be equivalent to the mass energy of an entire planet. Developing new sources of energy or methods to harness and utilize existing sources efficiently is a major challenge. In addition to energy requirements, materials science poses another obstacle. The materials required to construct a warp drive must withstand extreme conditions and stress. Developing materials with the necessary properties to handle the energy involved in the distortions of spacetime is a significant challenge for materials science. Ensuring the safety and stability of a warp bubble is also crucial, as any instability could result in catastrophic consequences, such as collisions with objects or unpredictable changes in trajectory. Extensive testing and simulations will be required to ensure the technology's safety. The development of advanced propulsion technologies also raises ethical and legal questions. Issues such as the potential for misuse, the impact on existing space treaties, and the management of interstellar travel rights will need to be addressed. Elon Musk's light-speed engine could have a significant impact on the space industry. SpaceX, as the company behind this revolutionary technology, could solidify its position as a leader in space exploration and travel. The success of the warp drive propulsion system would enhance SpaceX's reputation and potentially attract new partnerships and investments. Government space agencies such as NASA and the European Space Agency, ESA, could collaborate with SpaceX to integrate the new technology into their missions. This could lead to joint missions, shared research, and a more coordinated approach to space exploration. Other private space companies may seek to develop their own advanced propulsion technologies or collaborate with SpaceX. The competitive landscape could drive further innovation and accelerate the development of space infrastructure and capabilities. The ability to travel at light speed opens up new commercial opportunities, such as space tourism, asteroid mining, and interstellar resource exploitation. Businesses could explore new markets and revenue streams in the emerging space economy. Elon Musk's announcement has sparked widespread excitement and debate. The media has been abuzz with coverage of Musk's light-speed engine. News outlets, tech blogs, and science magazines have published articles analyzing the implications, potential, and challenges of the new technology. Coverage ranges from enthusiastic endorsements to skeptical critiques. Social media platforms have exploded with reactions from fans, experts, and skeptics alike. Enthusiasts are celebrating the potential for a new era of space exploration, while critics are questioning the feasibility and implications of the technology. Public opinion on the light-speed engine reveals a mix of excitement and cautious optimism. Many people are intrigued by the possibility of interstellar travel, while others remain skeptical about the practicality and safety of the technology. The future of light-speed travel holds immense promise. Although we are still in the early stages of developing this groundbreaking technology, the potential impact is nothing short of revolutionary. Technological evolution, through continued research and development, will likely result in further advancements in light-speed propulsion. New discoveries, engineering breakthroughs, and innovations will drive progress and bring humanity closer to realizing the dream of interstellar travel. The long-term goals of achieving light-speed travel focus on expanding humanity's reach into the cosmos. By overcoming the challenges and harnessing the potential of this technology, we could unlock new frontiers, explore distant worlds, and ensure the long-term survival of our species. The societal implications of light-speed travel could reshape human culture, inspiring new generations of scientists, engineers, and explorers. This could lead to a greater emphasis on space exploration and scientific research. To fully appreciate the implications of Elon Musk's light-speed engine, it's essential to delve deeper into the scientific principles underpinning this revolutionary technology. While the concept of achieving light speed has been largely theoretical, Musk's announcement brings a new dimension to these ideas. General relativity, developed by Einstein, revolutionized our understanding of gravity and space-time, predicting that the speed of light is the ultimate speed limit for any object with mass. The warp drive concept aims to manipulate the space-time fabric to allow faster-than-light travel. Instead of accelerating a spacecraft to light speed, which would require infinite energy, the warp drive contracts space-time in front of the spacecraft and expands it behind, creating a warp bubble that effectively moves the spacecraft through space at faster-than-light speeds. Quantum field theory and exotic matter also play crucial roles in this technology. Quantum field theory describes how particles interact with fields, and the creation of exotic matter with negative energy density is essential for maintaining the warp bubble. Though exotic matter is theoretical, researchers are investigating ways to harness phenomena like the Casimir effect to create the negative energy required for such drives. The energy requirements of a warp drive remain a significant challenge. Current models suggest that the amount of energy needed is far beyond what we can currently generate. Concepts like antimatter energy or harnessing black hole power remain speculative, requiring further research. Advanced propulsion concepts like the Alcubierre drive and warp ring are being explored, but they, too, face considerable engineering and energy hurdles. If light-speed travel becomes feasible, it could unlock unimaginable applications. Space tourism could be revolutionized, allowing people to visit distant celestial bodies like the Moon or Mars in hours. Interplanetary travel, which now takes months or years, could be shortened to mere days, making it more accessible for ordinary people. Scientists could also explore distant star systems and exoplanets, leading to groundbreaking discoveries and a better understanding of the universe. Light-speed travel could also make interstellar colonization possible, helping to address overpopulation and resource depletion on Earth. The technology could allow humanity to terraform and settle distant exoplanets, creating new civilizations beyond our solar system. Interstellar resource utilization, such as asteroid mining and harvesting materials from distant planets, could also provide solutions to Earth's resource challenges. Developing a light-speed engine is no small feat, and the path ahead will require extensive research and development. Scientists and engineers are conducting experiments related to exotic matter and advanced propulsion systems. Laboratory tests and simulations help researchers predict the behavior of such technologies and identify potential challenges and solutions. Collaboration between academic institutions, private companies, and government agencies will be crucial to advancing light-speed travel. Pooling resources, expertise, and funding will help stakeholders overcome the technical challenges associated with making this revolutionary technology a reality. Public-private partnerships, such as those between SpaceX and space agencies, can facilitate the development of advanced technologies. These collaborations provide access to resources, expertise, and infrastructure that drive innovation and research. International cooperation is also vital for addressing global challenges related to space exploration. Sharing knowledge and resources among countries can enhance the development of light-speed technology and ensure that it benefits humanity as a whole. Developing cutting-edge technologies like light-speed engines requires substantial funding and investment. Securing financial support from governments, private investors, and research grants will be crucial for advancing research and bringing these technologies to fruition. Governments can play a key role in funding research and development efforts through grants, subsidies, and investments in space programs. Supporting initiatives related to advanced propulsion technologies aligns with national interests in space exploration and scientific discovery. Venture capital and private investment can provide additional funding for research and commercialization. Investors are often interested in supporting groundbreaking technologies with the potential to disrupt industries and create new markets. The development of light-speed technology raises important ethical and societal considerations. As we move closer to making this technology a reality, it's essential to address these issues thoughtfully and responsibly. Ethical considerations include the potential for misuse of advanced technologies and the impact on global society. Ensuring that lightspeed technology is developed and used responsibly is crucial for preventing negative consequences and ensuring it benefits all of humanity. Advanced propulsion technologies could potentially be used for harmful purposes, such as space weaponization or unauthorized exploration. Establishing regulations and safeguards will be important for preventing misuse and ensuring that the technology is used for peaceful and constructive purposes. Another ethical consideration is ensuring equitable access to lightspeed technology. As advancements in space travel become more feasible, it's important to ensure that the benefits are shared broadly and that access is not limited to a select few. The societal impact of lightspeed travel could be profound, affecting various aspects of human life, culture, and the global economy. Space exploration and interstellar travel could inspire new cultural and social movements. The pursuit of new frontiers and the possibilities of encountering extraterrestrial life could shape our collective imagination and aspirations. The economic implications of lightspeed technology include the potential for new industries, job creation, and economic growth. The development of space tourism, resource utilization, and interstellar colonization could drive economic opportunities and reshape global markets. Elon Musk's revelation of a lightspeed engine represents a monumental step forward in the quest for space exploration. While we are still in the early stages of developing this technology, the possibilities it presents are nothing short of revolutionary. As we continue to explore the frontiers of science and technology, the dream of lightspeed travel brings us closer to unlocking the mysteries of the universe and expanding humanity's reach into the cosmos. The journey ahead will be filled with challenges and opportunities, but the potential rewards are immense. Toyota undeniably holds a prominent position in the global automotive industry. Even in the challenging year of 2022, they achieved remarkable sales of nearly 10.5 million cars. Toyota persevered despite the obstacles posed by the COVID-19 pandemic and chip shortages. So, what is the secret behind Toyota's status as a trusted brand for countless individuals? It all boils down to one pivotal element: their consistent production of exceptionally high-quality vehicles. Toyota cars consistently secure top rankings across various categories, whether sedans, SUVs, hybrids, or others. Toyota also provides a diverse array of models to cater to a wide range of preferences, ensuring there is an option for everyone. Another reason why Toyota vehicles are trusted and popular is that they retain their value exceptionally well. Even if you purchase a used Toyota, you can expect a respectable resale value when selling it. This is a substantial advantage. Additionally, Toyota fully addresses your needs when it comes to replacement parts. Their extensive network of dealerships and service centers spans the globe, simplifying the process of locating genuine Toyota components. This saves you the trouble of hunting for parts for maintenance and repairs and enhances the overall convenience of being a Toyota owner. Toyota's commitment to producing top-notch vehicles has fostered profound worldwide trust in the brand. With their diverse lineup, high resale values, and easily accessible spare parts, what's not to appreciate? However, there's more to Toyota's charm than just spare parts and mechanics. This is where the focus shifts to their engines and their dedication to research and development. Toyota has poured substantial resources into engine research, and the outcomes are clear. They have engineered some of the finest engines that have left a lasting mark on the collective memory of automotive enthusiasts. Currently, Toyota is pursuing a multifaceted strategy to attain carbon neutrality, and the potential for success is promising. The company boasts a rich history of trailblazing hybrid and plug-in hybrid vehicles, most notably with the groundbreaking Prius introduced in 1997. These innovative vehicles played a pivotal role in laying the groundwork for the current surge in electric vehicles. Despite this impressive heritage, Toyota has exhibited a degree of caution in fully embracing the all-electric trend. The controversy surrounding Toyota's reluctance to completely transition to 100% electric vehicles is a topic for contemplation. Various regions, including Australia, California, Canada, and the European Union, have already sanctioned the prohibition of gas-powered cars by 2035. This has put substantial pressure on automakers to shift from gasoline to electric vehicles as the drive to curtail carbon emissions gains momentum. In contrast, Toyota has publicly expressed its reservations by not endorsing the COP26 agreement, which calls for a complete shift to electric vehicles by 2040. The company has deliberately taken a cautious approach, arguing that the rush toward fully electric vehicles has overlooked several crucial considerations. Akio Toyoda, the former CEO of Toyota, faced criticism for taking this less popular stance. Toyota's approach is notably reserved compared to several competitors who have eagerly embraced the transition from gasoline-powered vehicles in favor of electric alternatives. Jaguar, a British luxury automaker, publicly committed to going entirely electric by 2025. Additionally, Cadillac and Volvo have announced their intentions to sell electric vehicles exclusively after 2030. Toyota, renowned for its legacy of pioneering cutting-edge technologies, has taken an unexpected and somewhat surprising direction. This move has garnered attention and curiosity within the industry, yet the rationale behind their unconventional decision is undeniably compelling. Toyota's reservations stem from a belief that a swift and total transition to all-electric vehicles may not be viable in the immediate future. Akio Toyoda has voiced skepticism regarding the electric vehicle (EV) frenzy, cautioning against an overzealous rush into EV adoption. He contends that an excessive increase in electric vehicles could pose potential risks. His argument hinges on the substantial cost associated with electric vehicles and the need for more infrastructure to support their widespread use, making such adoption appear impractical. It's essential to recognize that this viewpoint is somewhat concealed from the public because electric vehicles currently comprise only about 1% of the global automotive fleet. Nevertheless, as the number of electric vehicles continues to increase, the practicalities of the situation may become increasingly evident. The primary challenge looming when electric vehicles flood the market will be the increased demand for electricity to meet the power requirements of these vehicles. By 2030, the United States will need to expand its power output by 40%, equivalent to an estimated $100 billion investment in the existing electricity supply chain. Even in regions in Europe and Asia with advanced grids, the growing demand from electric vehicle users could strain the infrastructure. While voicing his reservations regarding electric cars, Akio Toyoda's concerns about a full transition to EVs reflect a cautious and strategic perspective. Akio Toyoda emphasizes the necessity of hydrogen-powered technology, anticipating that this innovative engine will disrupt the entire EV market. In addition to his concerns about the limited range of electric cars, Toyoda also raised alarms regarding the environmental impact of battery production and disposal. He pointed out the insufficiency of charging infrastructure in general. Toyoda's arguments hold substantial merit. Firstly, there is insufficient power capacity to sustain a mass transition to electric vehicles. Secondly, the world's primary source of electricity is fossil fuels, which means that a surge in electric vehicles won't necessarily reduce emissions but will merely shift their source. Akio Toyoda's critics may overlook his essential point: carbon, not combustion engines, should be the primary focus in the battle against environmental challenges. Looking at the bigger picture, it becomes apparent that the adoption of electric vehicles needs to be more consistent globally. While certain markets, such as those in Europe and China, rapidly embrace EVs, the United States lags. Meanwhile, some regions, like Africa, lack any meaningful EV infrastructure. This inequality underscores that the world is not yet prepared to commit fully to an all-electric vehicle agenda. Toyoda believes that transitioning entirely to electric vehicles would leave a significant number of its customers without viable options. In 2021, Toyota sold over 10.5 million units in more than 200 nations, securing its status as the automaker with the largest global market presence. The company holds substantial market shares across the board, particularly in underdeveloped nations with inadequate charging infrastructure. By 2035, these regions will likely struggle to establish the necessary infrastructure to support electric vehicles. Electric vehicles come with a considerable price tag. Although they are currently affordable due to government subsidies aimed at encouraging their adoption, the future of these incentives is uncertain, particularly once mass production takes off. Many potential buyers might hesitate to invest heavily in electric vehicles without these financial incentives. In response, Toyota has proposed a more practical approach, advocating for a balanced strategy that includes hybrid vehicles and all-electric options. The company is strongly committed to advancing hydrogen-powered vehicles as part of its strategic vision. Toyota aims to make hydrogen-powered vehicles a zero-emission alternative to traditional gasoline and diesel cars. To achieve this, they are developing internal combustion engines, ICE, that run on hydrogen, which could pose significant competition to the electric vehicle market dominated by lithium-ion batteries. Lithium is a critical component in these batteries, but it is not naturally abundant. Toyota is concerned that a looming lithium shortage may arise as electric vehicles are produced in larger quantities. Their solution involves shifting from producing large batteries solely for electric vehicles to creating smaller ones for hybrid cars. This approach helps mitigate the lithium shortage by utilizing more batteries with lower lithium content. Furthermore, hybrid vehicles emit fewer emissions compared to traditional gasoline-powered cars. The future of transportation, where electric vehicles dominate the roads, remains uncertain. Toyota, however, anticipates that an all-electric vehicle future will strain the world's metal resources used in battery production. In addition to lithium, there will be increased demand for nickel and manganese, two other essential metals in battery manufacturing. This heightened demand may affect battery costs, potentially impacting car prices. Toyota also argues that over-reliance on government incentives, which may be subject to change, is risky. Since only a small portion of new car sales currently comprise all-electric vehicles, there remains room for alternative vehicle types to enter the market. The company has opted for a different path, advocating for the hydrogen combustion engine. Now, let's delve further into why Toyota officials believe this technology could eventually surpass electric vehicles. Introducing the Corolla Cross H2 concept by Toyota, this innovative concept features a cutting-edge hydrogen internal combustion engine (ICE) prototype vehicle. The 1.6L three-cylinder turbocharged engine, known from the GR Corolla and GR Yaris, has been adapted to run on hydrogen. It harnesses Toyota's expertise in hydrogen technology developed through the Mirai fuel cell electric vehicle. The vehicle is equipped with robust armored fuel tanks, strengthened connecting rods, durable valves and valve seats, and fuel injectors, all optimized for gaseous hydrogen to ensure safe hydrogen storage. The Corolla Cross H2 concept offers seating for 5 passengers, and its features resemble a regular Corolla. In a thrilling development for automotive enthusiasts, Toyota and Yamaha Motor have united to develop a V8 engine powered by hydrogen. This 5.0L V8 engine, built upon the foundation of the Lexus RC Coupe's power plant, has undergone modifications to its cylinder heads and fuel injectors. Yamaha asserts that it will deliver an impressive 398 pound-foot of torque at 3,600 revolutions per minute and 455 horsepower at 6,800 revolutions per minute. These performance figures make it an enticing option, even though its power output is slightly less than a traditional gasoline-powered V8. One remarkable advantage of hydrogen is its ease of refueling. In contrast to liquid fuels, refilling a hydrogen-powered vehicle like the Toyota Yaris GR-H2 takes about a minute and a half, a notably faster process than refueling a conventional gasoline-powered car such as the Toyota Camry. Diesel fuel has historically been preferred for vehicles that haul heavy loads. However, in regions where temperatures plummet to negative double digits, diesel fuel can freeze. In contrast, unleaded fuel can withstand temperatures as low as -100 degrees Fahrenheit before freezing up. Lithium batteries can endure temperatures as low as -140 degrees Fahrenheit, though rare incidents can still occur. In contrast, hydrogen exhibits remarkable resilience, capable of enduring bone-chilling temperatures as low as -435 degrees Fahrenheit. This quality positions hydrogen as the optimal choice for extreme cold climates and underscores its adaptability to diverse environmental conditions. There are legitimate worries about the scarcity of essential materials, including lithium and battery-grade nickel, required for lithium batteries. These concerns could impede the production of batteries for electric vehicles. Leveraging the full potential of hydrogen-powered engines may be a strategic measure to mitigate potential delays in the transition to electric vehicles. One of the main challenges with electric vehicles, particularly automobiles and trucks, is the absence of the thrilling sound that comes with traditional internal combustion engines. Nothing quite matches the exhilaration of pressing the gas pedal in a classic muscle car, like a 1970 Chevrolet Chevelle SS with a big block 454 or a 1969 Ford Mustang with a 429 Cobra jet. The sound of the carburetor opening, the fuel surging into the engine, the power coursing through your chest, and the adrenaline rush are unique experiences that electric vehicles cannot replicate. However, hydrogen-powered vehicles offer a similar visceral experience. Nearly every corner of the country is home to small, local repair businesses, providing accessibility and convenience for hydrogen-powered vehicles. However, with the growing popularity of electric vehicles among consumers, traditional repair options may no longer be available. While you might attempt DIY electric engine repairs by watching online tutorials, consulting a certified mechanic with expertise in the latest technology is strongly recommended. One remarkable aspect of hydrogen-powered engines is their purely mechanical nature, resembling traditional ones. This means the local repair shops you trust can still effectively handle maintenance and repairs. However, it's essential to acknowledge that hydrogen has disadvantages, including high combustibility, challenging requirements for handling and storage, and nitrous oxide production during combustion. Toyota's approach to achieving carbon neutrality is notably diverse, as it explores various technologies to reach its goal of zero emissions. This contrasts with many other automakers that are placing their primary focus on electric vehicles. Given the ongoing energy supply concerns linked to the Ukraine conflict, European nations are seeking ways to reduce energy consumption. Switzerland has even proposed restricting electric vehicle usage to emergencies like errands or grocery runs, and this policy might become law. The future of hydrogen-powered cars holds potential with cutting-edge technology and hydrogen fuel cell electric vehicles, though their path to success may face obstacles due to the dominance of electric vehicles. Hydrogen-powered cars offer several advantages over traditional electric vehicles, such as extended range and quicker charging or refueling times. However, many technological advancements are needed for hydrogen-powered vehicles to gain widespread adoption. Currently, hydrogen production is costly and relies heavily on fossil fuels, and there is a lack of infrastructure for hydrogen refueling stations. Additionally, the popularity of non-hydrogen electric vehicles, like Tesla's, may pose a significant hurdle to the widespread acceptance of hydrogen fuel cell electric vehicles. People need a compelling reason to switch from their existing electric vehicles, and until such a reason is presented, hydrogen-powered cars may continue to struggle for recognition. The technology behind hydrogen fuel cells has existed for quite some time, originating in the late 1960s to provide power for NASA's manned space missions. Over the years, this technology has been refined and is now applicable for terrestrial vehicles as an alternative to traditional internal combustion engines. A conventional hydrogen fuel stack comprises an electrolyte membrane, an anode, and a cathode. Oxygen is supplied to the cathode while hydrogen is provided to the anode. The hydrogen is divided into protons and electrons. The protons pass through the membrane, converting into water, while the electrons are directed into a circuit, generating electricity. Hydrogen fuel cell electric vehicles utilize a robust tank of compressed hydrogen, which passes through the fuel stack. In contrast to conventional electric vehicles powered by battery packs, the vehicle's electric motors are driven by this converted electricity. In doing so, they emit only harmless water vapor from the exhaust. While one of the main criticisms of electric vehicles is their limited range, hydrogen-powered vehicles can address this issue. For instance, the Hyundai Nexo can cover 385 miles on a single fill-up, and the Toyota Mirai can travel an additional 402 miles, surpassing the typical electric vehicle range of around 250 miles. The duration required for electric vehicle charging is the second most common grievance among owners. Charging an electric vehicle's battery pack fully at home typically takes 8 to 40 hours. In contrast, refilling a hydrogen fuel cell electric vehicle is a matter of minutes, functioning much like the refueling process for gasoline-powered vehicles. Both Toyota and Hyundai offer complimentary fill-ups for their hydrogen vehicles. Toyota provides free hydrogen refueling for 6 years or up to $15,000, whichever comes first, and Hyundai offers similar terms, with 3 years of free refueling or a maximum of $13,000. Nonetheless, a pivotal challenge hindering the extensive adoption of hydrogen fuel cell vehicles centers on the need for more refueling infrastructure. There is a shortage of hydrogen refueling stations, with just about 60 in the United States, concentrated entirely in California, roughly 15 in Great Britain, and only a few in Canada. This scarcity of refueling options is a significant barrier to the widespread acceptance of hydrogen fuel cell electric vehicles. The cost of hydrogen poses another significant barrier. While automakers may initially provide complementary refills, owners eventually bear the expense. Hydrogen prices are on par with gasoline, occasionally reaching an outrageous $12 per gallon. To foster the success of hydrogen-powered vehicles, the cost of hydrogen must be reduced to approximately $2 per gallon, aligning it with the cost equivalent to electric vehicles. Another drawback is the claim that hydrogen fuel cell electric vehicles are less environmentally friendly than portrayed. The production of hydrogen consumes substantial energy, primarily sourced from fossil fuels, accounting for 99% of hydrogen production. While the vehicles do not emit pollution, their fuel production's environmental impact is notable. To increase public interest in hydrogen vehicles, it is imperative to find renewable energy solutions for hydrogen production. The key lies in developing essential infrastructure and discovering more affordable, environmentally friendly methods for hydrogen production. Given that this technology is still developing, it's reasonable to expect ongoing advancements in its application to power vehicles. Hydrogen fuel cell electric vehicles have the potential to become robust contenders against electric vehicles by aligning their cost effectiveness. However, even if hydrogen-powered vehicles were to reach a level of affordability and practicality similar to electric vehicles, battery technology is also progressing and extending range, potentially negating the advantages of hydrogen fuel cell electric vehicles. Electric vehicle owners may have little motivation to transition from a Tesla Model S to a Toyota Mirai when the performance is comparable. Ultimately, consumers tend to adhere to what they are accustomed to. Nevertheless, Toyota has garnered significant attention with its dynamic force engine strategy. This concept revolves around enhancing thermal efficiency. For example, Toyota has achieved motors with an impressive 41% thermal efficiency, a remarkable accomplishment compared to the typical gasoline engines with efficiencies ranging from approximately 25% to 33%. Ultimately, the decision rests with the consumer. Both battery electric vehicles and hydrogen combustion engine vehicles can significantly contribute to an eco-friendly transportation system. It's well recognized that these technologies are unlikely to replace one another. Instead, they will coexist and cater to various needs based on individual consumer preferences and circumstances.